right, I'm going to try this again. All right, the mass percent breakdown of water. If I take water at 18 grams per mole, and I want to know what the breakdown is. Hydrogen, there's 2 hydrogens, each at 1 gram. The total water molecule weighs 18, so we find that it is 11% hydrogen. And of course, oxygen has to be 89%, but we'll also show that by taking the 1 oxygen at 16 over the total of 18 and find that that's also 89%. Now the biggest thing here is, what if we had 456 grams of water? How would we know how much hydrogen, how many grams of hydrogen? Well, we just simply take 11% of it. I would find that we had 50.16 grams of hydrogen that I could get out of that. You can prove to yourself, we got two nitrogens here, each at 14. The total, I believe, is 60 times 100 will give you the percentage of nitrogen in urea. And ammonium nitrate, you also have 2 nitrogens at 14. I think the total thing weighs 80 grams though, and you get a higher percentage. So we can also use this for hydrates, the particle that has water molecules loosely attached to it. The percent water. Well, what we want to do to find percent water is we're going to take those 5 waters, so 5 times 18 grams, over, and if you add up everything, add up 1 copper, 1 sulfur, 4 oxygens, plus 5 waters, you will find that you will get, I think, let's see, yeah, 36% water. So the question is, well, if we have 600 grams of this whole thing, how much water could we get out of it? Well, 36%. So we should be able to get 216 grams of water out of that. All right, so empirical formulas, you can read through what you have to do here. This is the definition and an example. So I'm going to skip this, go to this one. The first thing you want to do is you want to convert to moles on each of these. And when you do this, you want to make sure that you use 3 or 4 sig figs. So notice how I have that many sig figs. I'm going to get 0.006667 moles of lead. And notice I'm going to keep 4 sig figs there. Here, instead of hydrogen just dividing by 1, I'm going to go ahead and divide by 1.008, keeping those sig figs again. And I'll find I have that same number of moles of hydrogen. And with arsenic, again, you'd probably round that to 75 normally, but we're going to keep 74.92. And it turns out you actually get that many moles of arsenic. That can happen sometimes. With oxygen, we're going to divide that by 16.00 grams, and you find to have 0.026668 moles of oxygen. Now, the second step, as you read, is that you take all the numbers you find and you divide by the smallest one. And the smallest number here is this 0.00067. And if I divide each of these by it, of course, I'm going to get 1. If I divide this by that, I am going to get almost exactly 4. And you should try that out in your calculator because you need to get very close to a whole number at this point. This has to be a whole number. You can't have just kind of close to a whole number. So the empirical formula, lowest ratio, is that. Now it could be bigger, it could be twice as big, 3 times as big, who knows, but that is the lowest ratio, whole number ratio. Okay, so if you get grams, you simply take the grams of each thing, a percentage, you take the grams, and you convert those over. And then you're going to do the same process. You're going to divide by the smallest number. Okay, and the smallest number here is obviously 1.23. So I'm going to divide both of these. And obviously here I'm going to get 1. Get really, really close to 7 here. Really, really close to 6 there. So the empirical formula is C6H7N. That's its empirical. Could be twice as big. Could be C12H14N2. Could be 3 times as big. Okay, so in this particular case, I'm going to leave you to convert this to moles of aluminum and this to moles of oxygen, divide by the smallest number. And what you find for aluminum is 1, and oxygen is actually 1.5. And this you actually hope to be a nice whole number, but if it isn't, and you know you've done everything right, simply go ahead and multiply by 2. So now what you have is the empirical of Al2O3. And if you remember back, we did the charges. The charges actually fit this, don't they? Plus 3 and minus 2, you would predict that as well. Okay, we're going to come back to that and come back to that one, I think. Okay, the true molecular formulas come when you have your simplest whole number ratio and you have to find out, what is it really? Is it 2 times as big, 3 times as big? Maybe it's the same size, who knows? So this is how you find. You find the empirical unless it's given to you. You add up the mass of the molecule of the empirical and you compare it to the true one. Now this one has to be given to you. We don't have the skills yet to find out what that is. Okay, so for instance, CHO2 is going to be 1 carbon plus 1 hydrogen plus 2 oxygens. That should weigh 45 grams per mole. Another way to say that, of course, is 45 AMUs per molecule. And now we're given that 225. We're going to go 45 divided into 225, and we find that it goes 5 times. So the real formula is C5H5O10. That's its real formula. Okay, so caffeine, lastly here, you may end up having to find the true, the empirical formula before you have to find the true formula. But again, you're just going to take these numbers and you're going to convert 2 moles. You're going to divide by the smallest number, you'll find the empirical. Now, it turns out that I believe the empirical should be C4N2OH5. I believe that's correct. And then what we find when we add that up is 97 grams per mole. And if we take 194 and divide by 97, that goes in 2 times. So the real formula is C8N4O2H10. That's the real formula because 97 goes into 194 2 times.